quick agenda for today. I'm going to do an intro to Redux. Then I'm going to talk how to integrate it into your iOS project and some conclusions and takeaways from my experience of using it in a production project. To make it more useful for everyone, let's do a quick round of hands. Who of you have heard of Flux? Well, that's quite a lot. Cool. Who of you have heard of Redux? Great. All right, I'm gonna do intro anyways because we have to be familiar with concepts. But I will make it quick and then go straight further to the fun part, which is code snippets and so on. All right, so model view controller. You all know this stuff, and you probably know the problem with it. Well-known one. It's the controller here, and the problem is that it gets massive with time, right? The other thing is, okay, let's go forward. So that's an alternative to that, which is Redux, and you already see it's completely different, but not going into details. Let's take a look at just errors. So you see, it's already this unidirectional flow. What does it mean? It means, let's go back to the previous slide and see the difference, right? Here, if you are coded in some particular class, you could probably be, where did I come to here? Where did I go from this place, right? So you have to understand the code, you have to understand the flow. With unidirectional flow, you don't do that. Here you are in some specific place, right? And you are pretty sure. If it's, let's say, store, I just came here from an action, right? And where do I go from here? It's gonna be view. Just very simple idea of it. So unidirectional flow makes it more readable. Now let's talk a little bit about concepts here. So first one, it starts with an action. Basically, action is a very dumb thing. It's just an intention to do something. It can be a string or a num. It's super simple. Just we want to do something, right? Then it comes to the store, which has app state. App state is the data structure which contains all your application state. All of it. Then we have state distributed to the observers. In this case, this is view. So your view gets notified when your state changes. That's how it works at a glance. Let's move forward, and you might wonder how magic happens in this store, how we get a new state, right? So it works with reducers. I'm gonna do it super quick, and you will understand it when it comes to the code. So basically, you have an action, you have intention to do something, and this intention will change your state. How it works? It works with reducer, so there is some function which changes your state and generates a new one. That's one of key components of Redux, reducer. It's a pure function. It takes as input action and a current state, and it generates a new one. That's it. That's all it does. And thanks to its functional nature, it's testable, and it's supposed to have no side effects. Okay. The idea of the Redux and basically the idea is that UI is a function of state. Everything what happens to your UI is just a function of state. It just reflects on your state change. You update UI whenever you update your state object. That's how you update UI, by changing your state object. If you think about it, in Redux, that's the only thing you do. Everything you do, you just change your state object. And your app reflects that change. That's it. If you think about it. That means at any moment in your app, you know the whole state of your app, right? And the state is just a data structure. So that means we can simply say it. That means we can also save it whenever it changed, so that we can have a history of state, history of how we change the state. This allows to do pretty cool thing, which is time travel. Let's see if this works. That's just a quick demo. That's how you go in the future, and that's how you go back in time. Because if at any moment you have a state, and you can save that state, that means you can easily switch between states. And if you change your state to the previous one, to the one which was a minute ago, you can easily have a UI from that. That's the beauty of Redux. Just quick introduction to the idea. Now I'm gonna show how it looks in code, how you can create a project with it. Okay, I think I have to sit like this. Sorry, guys. All right, so that's a demo project, which is super simple. Yeah. Good point. Yeah, like that. Right. Okay, it works. So this is the app, which simply increments counting. That's it. Okay? How does it work? Let's start from the app state. So I'm using a framework to implement Redux. It's called Reswift, and it's written by Benjamin Entz 1 year ago. You don't have to use a framework. You can come up with your own implementation. You just have to understand the flow, how Redux works. But I think it's a good idea to start with a framework to understand patterns, how it's already built. So I'm gonna be showing how it works with the Reswift framework. And it starts with the app state. It's simply just a structure with one property, counter. It has initial value, that's it. Then, you already seen how it works with the project, right? So you press a button and something is happening. Let's take a look where is it happening. So we have your view controller. When you're using Redux, it's not a view controller anymore, it's just a view. It's simply as dumb as possible. You have an IB action when you press a button. What we do, we dispatch it to the store. That's it. You have an action, you dispatch it to the store. That's all the function of view controller in this place. Let's go forward and see what's happening next. So, since we are using Reswift framework, it takes care of dispatching things and it invokes reducer. Remember, pure function, which does the work. Here it is. You have to implement reducer, you have to make it conform to the protocol, and you have your business logic inside. Now, if you think about it, with Redux, where you have your business logic, you always have it in reducer. You can have multiple reducers. Each one can have its own responsibility, its own separation of concern. But the thing is, you put your business logic into reducers. So here it goes. It reacts on the action. This is your action. It increments the counter, and it returns a new state. If you remember the picture, that's exactly how it was. It gets action and current state as an input, and it returns new app state. What's happening next? Basically, that's almost it. Once you return the app state, new one, again, framework takes care of it. It notifies all the subscribers, everyone who's interested into seeing new state, updated state. In this case, we come back to the view controller, and you see it contains the protocol store subscriber, which also comes from the framework. And what you do in view will appear, you subscribe to events, right? That means you have to implement this method, to be notified. Once you have new state, you update your UI. That's it, that's the flow. And if you will disappear, you unsubscribe because you no point of updating UI if you is not visible. That's it. Let's go to the next. Let's imagine we would like to improve something. We'd like to add some more business logic to your code. Where's my mouse? Okay. We go to the app state and we add a label. Maybe I should run it to see what I'm talking about. Here we go. Now, if I keep pressing +1, it becomes yellow. That's additional business logic. So how do you implement that? You introduce another variable in the app state, right? Then you go to your reducer and you come up with some business logic for that, something like that. And then in your view controller, you simply have to add one line. You update UI accordingly. So nothing else changed. You still get your state when it changes, and you update UI. One more thing. I already mentioned we have business logic in reducer. That means the only thing we have to cover with tests would be reducer. So here it is. Here is how you write test for reducer for your business logic. It's actually quite simple. You create a counter, which reducer, which you're gonna test. You create a state, just empty one, and then you just trigger reducer. That's actually what framework does for you. You just trigger reducer, you give it an action, you give it current state, you have result state, and you assert. You just make sure that's what you expect. Since we have a new business logic here with a color chain, you are doing exactly the same. You create a state, that's another test. You create a state, you give it counter with 2, you trigger a reducer, and then you check, is counter what you expected, and if color is changed. Let's move forward. At this moment, you might wonder, okay, we have this main store, which is declared in a global scope, so every class can access it. And every class can access every part of it. Isn't it a huge God object, huge dependency all over the project? How are you going to maintain the code in a huge project? That is true, and there is a way to address this valid concern. Let's take a look how we're going to do this. So we have app state. I introduced a few more properties just to show that we can have a lot of stuff here. Some properties for another screens, another functionality, right? But for our view, we still only need counter and a ground color. That's the only thing we need for that view. So now comes the idea of substates. The idea behind is that you only expose particular part of your app state to some view or to some reducer. Because your view only interested in those two properties, so that's it, let's expose those two. How does it look in a view controller? That's the syntax which comes from the framework. With your own implementation, you can make it differently, but the idea is exactly the same. You still subscribe to the updates of state, but here you list the properties you are interested in. So you are not really, you don't really care about every tiny change of the app state. You only care about change of those two properties. So you subscribe to those two. That's the only change in the view controller, and exactly the same rule applies to the reducer. Let me go back to the app state. So again, this is your protocol which describes substate, just only slice of your state. In the reducer, everything is changed now so that it only knows about your substate. It gets it as a parameter, and it returns the substate. All right? Code is exactly the same, but now reducer is agnostic of the whole app state. Okay. Where is my mouse? That's it for the code demo. I think at this moment, if you, we still have third part of the presentation, which is conclusions and some takeaways. But if you have questions about code, shoot.
Yeah, thanks for that, for the demo and for presentation so far. My question is, the app state is right now a struct.
Yes.
That means it gets copied all the time. I mean, if you have
it's not getting copied. You never press it.
But it's a value type, so every time you call a function with it, you get a.
If you are talking about reducer, then yes, of course. That's actually the idea of it. It's a struct and it gets copied. Reducer gets a copy of it, does its own manipulation according to the business logic, and in return a new one. So at that moment you exchange the old one with the new one.
Yeah, but that means if the state is really big, you have a lot of memory consumption and copying back and forth, and that probably gets really slow.
That's a valid question. If state is huge, it comes with overhead. But the thing is, just a second. The thing is, in your app state, you don't have to necessarily keep every single image or huge data pieces or some tables from database. You don't do that. For instance, if you have an image, what you keep in your app state, you keep an URL to it. And you have some caching class so that you can easily restore your current app state by what you're having in the app state struct. So it's supposed to be still more or less small.
Maybe let's do the Q&A round.
So I just want to say, Swift is very quick about copying structs because it only copies on write. So if you don't actually use the other struct in the lot, then it will not copy anything in the memory. So even though it says it copies, it only copies when it's really necessary. So yeah, I did in the Swift workshop, we also talked about this just recently. So it's actually like if you measure it, it's very
also a stack copy, which is almost for free. So
yeah.
There's no heap allocation.
Okay. And more questions about code?
And another thing to add, that's basically the idea of functional programming, of pure functional code, that it shouldn't produce side effects and produce new data structures with every use.
Yeah, that's correct. If you would use a class instead of struct, that means your pure function remains a reference to the somewhere else, can change it, can break something. That's not how it's supposed to work. You get a state, you have a copy of it, you change it, you return it. So your app state is updated.
Thanks for the talk. Just want to ask you, how would you handle animation or transition between views? Where all this logic will fit in another user, or should be in the view? Because for like native transition is okay, but it involves more logic. Where would you?
It gets tricky with animation. So the question is how you handle animation, and if I understood you, how you keep your animations in the app state. Is that correct?
Complex animation has transition animation.
Yeah, that's where it gets tricky. It's still possible to keep in your app state things like animation started and animation finished. You can do that, but it will come with some headache. Navigation state, though, is handled quite well with this framework. It already supports a navigation stack, so that you can simply keep in your state whether you are in this on that view controller and how did you where did you come to it. Okay? More questions?
Yeah, you talked about keeping the app state database tables, for example, right? Or you should not keep database data.
Yeah.
Something like that. So if you have records from a database, right, like for data, for example, they come out as managed objects, right? Which means if you have a function that has a side effect on the database, these values will be changed. So how do you rewind the state at that point?
What was the question exactly?
The question is
Last part of it.
if you have classes in your state somewhere, something that is a class, right? And you make a change to this class, right? The change will be, how can I say, will be carried over throughout the lifetime, throughout the lifetime of the state, right? So if you want to rewind to the previous state, right?
Yeah.
How do you rewind to the previous state if you have a class? So
Is it still a question about database?
well, related, yeah.
So the idea is that you don't keep your whole database in the app state, right? So mostly where it comes from, it's about UI. It's about something which is visible to your user, or something which has effect on UI. So that you keep in your app state everything you would like to be kind of synchronized in your app. Whenever you change something in your database, and if it's visible to user or somehow valuable for the work of your app, you're supposed to update app state as well. For instance, you keep users in your database with lots of fields and so on, right? So whenever you change that, you update your app state, but in app state you keep your users in more representable view, right? So that it can be presented to user. Actually, this question leads to the next question. How are you going to use Redux in your project, which is already old, maybe with some legacy stuff, and you would like to introduce that framework? Just to summarize the code demo, a quick slide about substate. Remember, you don't want to expose the whole app state to every part of your app. So what you do, you expose only substate to each of your reducers, and you expose only some substates to your views. They only subscribe to specific fields. Okay? Now, let me try to answer your question. That's kind of your app structure, right? You have usually big, massive view controller, massive view controller. You have your services providers, something. Usually you have singletons in reality. You have database and network, and when it comes to Redux, it's somewhere here. And why it's that big? And notice that view now is really thin. It's dumb and small. So now the idea is, you have a database with your users. How are you gonna change that? You don't change it directly anymore. You don't go to your repository, which will write to the database and so on. Now, if you wanna use Redux, you're gonna send an action. You emit an action, which is intention to do something. In your case, it would be add new user. So it starts with this big green block. Having an action, some according reducer will be started, and it will do all the business logic. In your case, it will be update the database, maybe trigger some API, maybe track something, and of course update UI if needed. So everything goes through Redux. And of course, if in your reducer you have new user, what you're gonna do? You're gonna add this new user to your app state. Does it answer your question?
Partially yes, partially no. Because you showed that the state was rewindable, so you can rewind the state.
That's correct.
Yeah. So if you make a change in the database, you also have to know how to make the inverse change.
Yeah, I think it doesn't work that good. Yeah.
One more question. Thanks first for also this practical approach. I would like to know that how is it if you have some experience with bigger projects with it? Because I think maybe debugging could be still a bit difficult if you always expose actions and then they have a big state and you don't know at some point
works, but I'm gonna tell you. So there is, you already have included at any point in your app, you have your app state, right? And you throw an action. So each reducer that you have gets triggered whenever you have new action. It invokes all the reducers. So one of them, or each of them, if you want to, you can put breakpoint, and you can see what's the action currently. Or you can put a breakpoint for a specific action and see, here you go. You can print it to log or something. You see, this is a specific action, and most beautiful part of it, you see the whole app state when you are doing it. So actually debugging, first of all, as I already mentioned, unidirectional flow comes, it makes project extremely readable. You can go only, if you follow the logic of the app, you can go only into one direction.
So reducers are always triggered after an action, not like in a specific point of the life cycle of the.
This is how it works. You have an action, it's dispatched by a store, and then store invokes all the reducers. And addressing your question now in more extended way, there are also such concepts as middleware. That's a pretty powerful thing, which is again purely a function, and it gets executed before reducer. Actually, I'm not quite sure before each reducer or before all of them. It is executed, and that basically means that you have some place in the code where you see, okay, now we have the current state, and we're gonna start executing reducers. You can print an action, or you can debug an action. You can see current app state. Then reducers, all of them are executed. All of them are done, and you again have the middleware. So you can again print an action and the app state. So it makes it quite debuggable. You will see the action is add user. Before we had 5 users, after that we have still 5. Must be a bug in this particular reducer. Okay, maybe I should go on with the talk. We just have a few more slides, and then if you have more questions, I'm happy to answer. So, all right. As I already mentioned, Swift is a pretty cool library, written with Swift 3, covered with tests, extremely completely functional. It's a piece of art. Can only recommend that. And from my experience of using Redux in a real project, time traveling is cool. Having the whole app state is great. In reality, it comes actually with overhead. In reality, and here in Cocoaheads, we are using Redux actually in 3 projects. One is web frontend, second is React Native project, and third is native app, native iOS I'm working on. So we implemented this version of Redux, iOS version, in the native project. And in reality, I didn't keep all app state data structure. I only kept the things which are available for the whole for the life cycle of the whole app. For instance, whether user is authenticated or not. Things like that. That's just my experience. There are some pros and cons with the framework and Redux itself. Let's start with the good stuff. So, unidirectional flow makes it really readable. The whole theme, doesn't matter you use the framework or you write your own implementation, it will be completely functional, which makes it testable and hopefully no side effects. If you remember the picture, it comes with really good separation of concern. You have your view, and it's not a massive view controller, something, how it usually with Apple, right? Now it's just a view. It's just a view which get notifies when something changes and updates. You remember action. Action is just the declarative way to explain your intention. We're gonna do something. You don't have to test it, there is no code inside. You have a store. A store has an app state, just one single one. Obviously, it's concerned to have to keep the state. And of course, you have reducers. You have multiple reducers. For each purpose, you have its own. You have, for instance, for working with users, you have some users reducer. For authentication, you have another one. For every another topic, you have another one. So it comes with a good separation of the server. In my experience, our current native project is written with Viper. I want to say completely, actually. And surprisingly, Redux works pretty fine with Viper. It's not part of this talk, but if you are interested, just find me here afterwards. And some cons. The framework I'm referencing to, Swift, is written by one guy 1 year ago. Documentation is not always updated, and so on. It's a really new technology in iOS. And as I already pointed out, AppState is a God object, anti-pattern. It's accessible from everywhere, so you have to really do your best to split it to some parts and keep track how much you expose this AppState to another parts of your project. What else? You don't have much time, right? Okay. From my experience, when it can be useful? Obviously, for apps with lots of global states, such as games or, I don't know, apps where you have some state which is supposed to be updated in every view. Did it ever happen to you that you are using iOS app, you are changing something on one screen, you go to another screen, and then it's not updated? Like you are editing something, you are pressing back, and then screen is not updated. It happened for me a couple of times. That's something which will never happen with Redux, because you change your app state, all the views will be updated. As you already saw, the history of change and time traveling, basically, if you are doing something like Microsoft Word but on iOS and you need undo and redo buttons to go back to the previous state, that's what you can do with Redux, pretty simple. If you think about it, everything you saw, actions, store, reducers, views, and so on, everything is asynchronous. The only place where you should be synchronous is when you have a new state and you update your current app state. That's the only thing that should be done in a thread-safe manner. Everything else is asynchronous. The whole approach is, by its nature, asynchronous. So it's super easy to work with async stuff. And imagine if you are using the app and you have requirement for user, if user closes the app and starts it in 2 weeks, we would like to put user exactly in the same place where he was to kind of restore his session. How are you gonna do it with Viper, MVC, MVVM, and so on? It becomes super tricky. With Redux, it becomes a piece of cake. Just save your state, put everything to your app state, and save a history of it. Then you start the app, you simply restore the last state of the app. I think that's it. You can find presentation on SlideShare. You can find some links about Swift and Redux in general. There is this talk from the guy who wrote the Swift framework. I can only recommend it. It's a piece of art. Great talk. And my contacts if you want to keep in touch. Questions? Question back there?
Do you hear me? Okay, so you say that the states are global, right?
Yeah.
So everything can get an access to it. And I have a question: what happens if like several new controllers will try to stay in the same state?
Try to do what?
To change the same state, like how you implement this like one by one, according to.
So that one of my ideas of the whole you don't change your state. Think of your state as a mutable thing. You never change your state. What you do, you only send actions. You emit an action which identifies your intention to change the state. Then reducer will start. As we already clarified, reducer will get a copy of the state because it's a struct. Reducer will apply business logic to it to get a new state. And then that's the only synchronous part in this whole thing. When you have a new state, it will exchange it. Does it answer your question? Again, you don't change your app state from view controllers. From view controller, you send an action, a synchronous action. And again, from your view controller, you send an action and then you wait. You wait for a new state.
From one controller, you send this like action, and then this view controller will change state, let's say A. And then another controller doesn't know anything about it. Controller A changing the state. So it can also potentially like, get a copy of that state and change it. How do they like synchronize at the end?
You don't. You send an action, and second the controller also send another action. Both of them are executed and state is changed.
It's going to be on a serial queue.
Yeah, I guess that has something to do with that everything except the view part is async, but the view part is synced.
Actually, yes. When you get that new state update in a view, you explicitly in the main state, it was in the code actually, in the main thread, you update your URL. Good, next. There.
Where do you put your side effects if you don't put them in the reducers? You talked about the middleware. So if you want to add a new user to your database or to your web server, you're going to click a plus button and then it's created. So the action would be new user, and the middleware would, like the middleware you said is also just a function that takes an action in the current state and produces a new state, right?
Now, reducer does that. Reducer takes the current state, takes an action as an input and produces a new state. Let's not get into middlewares, let's only talk about reducers. So, your question now?
My question would be where to put the business logic for creating the new user either in whatever core data or syncing it to the web store, because that's
Reducer.
really, like in the reducer.
Yeah,
that's
it's a business
side
logic,
effect.
it should be in the reducer. Of course, you're supposed to have some facade to hide your database and API and so on, but business logic should be in the
But
reducer.
isn't that a side effect?
No, that's the purpose of reducing. Side effect would be if your reducer have references to another services, something, and start doing something with some another objects which also have a state. You may be thinking that database can be triggered from different parts of your app, right? But the idea is you always now if you are working with your users, you have users database, right? And you want to change it somehow. All your classes and projects should do this via actions, not directly to the database, just via actions.
So basically the reducer is the only object that has write access to the app state, correct?
Logically, yes.
Okay. And isn't then the reducer, is it handling every action that can happen in the app, or can you somehow split it up, because otherwise I think you would get a giant reducer object?
In my example, reducer does everything, and that's how it's supposed to be, but in reality you have 5 years or 10 years project. Okay, not 10 with iOS. But the idea is you have users, you have authentication, you have, I don't know, deals, whatever, and other entities. How you start introducing Redux into your project? You take one screen or one feature, and let's say this feature will be users. And yes, at that moment you have to make sure that everything which will change your users, create, delete, whatever, should go through the reducer. That's the way to get rid of side effects.
But can you have more than one reducer or just one per app?
You should have more than one reducer.
Oh, okay.
Each reducer should have its
Can
own
change them.
responsibility.
Okay.
Chain them, or you can have few users per substate.
Now if you think of your app flow as changing of states, let's say you would like to track if you come from screen A to screen B. How are you going to do that? It's pretty simple. You don't have to touch your screen A or screen B or something else. If you change your navigation state, you just put small middleware and it finds out, okay, before it was screen A, then reducers do their job, and now it's screen B. So that was a transition of the state. And you can implement tracking or logging or whatever right away. More questions?
Maybe another question. So if creating a user on the server is in the reducer, and the reducer directly should return the new app state, how can it do that if the function, like inside the reducer, everything should be synchronous, but actually this would be like the successful creating a user would be in the completion handler of any.
Correct. Thanks for a great question. It's absolutely valid. So if you think about it, what a reducer will do, it will start an asynchronous job, right? And when this job is done, in somewhere in the completion handler, in maybe another class, doesn't really matter. What you're gonna do when you have your JSON from server in a synchronous way? If you think about it, you have your JSON with new users. That means you have to change your app state to the new users. What you're gonna do? You're gonna send an action. You're gonna send an action with intention to change your users accordingly. You're gonna give this JSON as a parameter to that action, and some reducer will handle it. Another reducer, or maybe the same one, but another, and it will do it in a similar synchronous manner. So in this story, in the use case you described, we have actually two actions. First action would be to start updating users, like refreshing users from server, right? So your reducer, what it does, it starts the job. Then we have second action. The second action is, okay, users are updated. We have JSON with new users. Then second action goes dispatched to the store. Second reducer gets executed and handles it.
And would the first reducer return the same app state that it got in? No.
Depends on what you want. It can be either same state, because you still have same users, right? But what can change is actually you are now in the refreshing users mode. That you can save in your app state.
Yeah.
I think we don't have time for more questions now, but I will stay here.
One more.
Should.
Let's say yes. Just maybe I missed something, but what is the idea behind having just one global app state rather than maybe smaller states?
Let me answer with a picture. Where do you think the state is here in this picture? I hear model, something else? No. In my experience, it's everywhere. In my experience, state obviously in the model. It's definitely in the view, because you have some label, background, whatever in your view. And sometimes in projects where more than one person works on, you have state in your controller. And eventually you have code which has to handle all of it. It has to check what's in the model, what's in the view controller, what's in the view. You have to implement logic to deal with that state. So what Redux does is addressing that issue and trying to have one source of truth, one single app state.
I understand that this is like the extreme of it, but
Yep.
you have somewhere in the middle where you have like states.
No.
No.
You never have another state. You remember, middleware and reducers are purely functional. You get state as an input You return it as an output. You never keep it.
I agree. Just, okay, maybe I rephrase that. You have like usually like several features in your app, right?
Yep.
So you could have state per feature rather than global state for the whole app.
So your question, is that better?
I'm asking you like, why? I mean, if I want to implement right now in my app this, then my app state will be huge and won't work.
Yeah. So two things about that. You don't have to put every tiny part of your app state into the app. In a classical Redux, you have to do this. You will have everything. But in my experience, don't do that. Only keep in app state things that matter for the whole app. That's first. Second, you can actually have kind of its own store for each component. And then you will end up with Flux. That's exactly what they do in Flux. For each component, they have the whole unidirectional flow. They have store, action, and so on and so on. That's just another pattern which is broadly used in React.js. And Redux actually is kind of evolution of it, for good or bad.
Okay, I'm sure there is plenty more questions, so and so now we will have a break and you can use this